Hey guys, welcome to my YouTube channel. I'll be solving LeetCode 75 list using Go programming. So let's look at today's question is subsequence. Given two strings s and t, return true if s is a subsequence of t or false otherwise. A subsequence of a string is a new string that is formed from the original string by deleting some of the characters without disturbing the relative position of the remaining string. So let's go back to the drawing board and understand the example. So here in the example you have s and t. So let's check whether there are if s is a substring of t or not. So we have example ABC and AAC. So A and A match, and then this second A and this A match, and this C and this C match. So we can tell it's a subsequence. So for a string to be a subsequence, so let's say you matched A here with this A, and the second character A should match with the character which is after this previous match, which is A. So see, this A occurs after the previous A, and then again this C gets matched after the previous match, which is A. So only if it occurs in that order you call it as a subsequence. And yeah, that's basically what you need to understand about the question. And also, if if they have to match consecutively, like let's say you had to match like ABC, and if you are matching, if you were checking if AAC together contiguously occur anywhere, that would have been substring. So that is different. Substring means all the characters should occur consecutively together. That is different, that is substring. But in this case we are finding subsequence where only the relative order of the string should be maintained. As we saw, the next A should occur only after the previous A, and C should occur after the previous match. That order, relative order, if it is maintained, that's enough in this case. So let's see how we can solve this. Okay, let's rewrite the example ABC, and then AAC. So if you've seen my previous videos, I've discussed about the concept called two pointers. We are exactly going to use the same here. So two pointer, as the name suggests, has two pointers. So here it is I and J. So let's see if A and A matches. They're matching. As soon as there's a match, move I, and then J keeps moving. A and B doesn't match, keep moving J. C and A doesn't match, keep moving J. A and A match. So as soon as there is a match, you move your I. Keep moving. B and C doesn't match, keep moving. C and C match, so I moves at the end. So at the end of the string, I will be equal to len of S. So if I is equal to len of S, that means it's true. We return true because we found a subsequence. It's as simple as that. If it is not equal to len of S, that means we were not able to find subsequence. So I hope you understood that. Now let's go back to the editor and start writing the code. So we'll have like two pointers. I is equal to 0 and j is equal to 0. J is less than len of t, and it's also should be less than len, sorry, not s, I also should be less than len of s, and then j plus plus. In this case, if s of I is equal to t of j, if it's a match, only in that case move your I. And at last just check if I has reached the end, which is len of s. If it is, return true. So let's check this code. It works 100% runtime. So what is the time complexity here? Time complexity is we are basically traversing only once. Um, Basically, we traverse till the length of the string t, and we basically traversed length of string t and try to find if any of the characters keep matching with string s. If it matches, only then we increment. So in this case, the time complexity can be taken as O of len of t, time complexity, and then space is O of 1 because we are not using any extra space. And then we also have a follow-up. Suppose there is lot of incoming s, like s1 to sk, and you want to check one by one to see if t is a if it has t as its subsequence. In this scenario, how would you change your code? Check if one by one to see if t has its subsequence. Okay, so how would we change this code? This is an interesting question. So let's go back to the drawing board. I will explain it to you how we can do this. So here is this. Yeah. Now they're telling we have s1 to sk. We have multiple strings that is coming in a stream, and k can be very high. It is like can be greater than or equal to 10 power 9. How will we solve this? So in the previously, we had a string t, we had a string s, and we had like pointers I and j, which we kept checking for both s and t by traversing them. If you do that for all s of k, this will be very exhaustive. This will be like very exhaustive, especially if string t is lengthy, it will be very exhaustive. So what can we do to optimize this? So one approach is I'll first write down the steps of the algorithm that I'm going to use to solve this, and then I'll do a dry run and explain you why this works. So don't watch this video till the end, because there is a lot of explaining to do. So you might get confused in the middle. So watch till the end so that you understand it fully. So yeah, let's start with it. So the first step is cache t. So create hash map for t where the key will be each character, for example a, which part of t, and value will be a list of indices where that string occurs, like 0 comma 3 in case of a. So we'll create an hash map like this. After creating an hash map, what do? Then we take each individual string. Let's take s1 for example, and then we traverse each character in s1. Let's say s1 is ASC. We traverse each character, and for each character we check if it is present in the hash map. If it is present in the hash map, we will retrieve the indices associated with the hash map, and then we'll also have a position which is equal to -1 initially, and then we see if there is a indices which is immediately greater than -1 in this indices list. If it is there, we just update it to that. So this is the process we will be following. I know you wouldn't have understood completely. So this is just an outline that we are going to follow. Now I'll do a deep dive and explain you with an example so that you'll understand much better what exactly we are going to do here. So yeah, let's take an example. Same example only we will do. So create an hash map first. For t, hash map will create a occurs at position 0 comma 3, 0 1 2 3. B occurs at 1 comma 4, C occurs at 2 comma 5. Now each string s1, s2, s3 we have to process one by one. For now, let's say there is only one string. So AAC comes first in the stream. We retrieve the first character A. See whether A is present in the hash map. A, B, C, A is present in the hash map. If A is present in the hash map, then retrieve the array representative of it 0 comma 3, and as I had mentioned, position initially is -1. Check if there is an index which is greater than -1 in this array, so 0 is there, so update your position to 0. Update your position to 0. Now go to the next character A. Again retrieve the indices associated with it because A is present in the hash map. 0 comma 3 will again be retrieved. Is there a position greater than 0 here? It's there. 3. Update your position. The reason why we are updating position is because, as I had explained it to you earlier, for subsequence, wherever the previous match is, the next match should occur at an index after that previous match. So we are basically using position, we are trying to track the location of the previous occurring match, basically that. So position is updated to 3, and then we'll go to C. Sorry, we go to C. C is present in hash map. Retrieve the indices 2 comma 5. Is there a position greater than 3 in this indices? Yes, 5 is present. So for each of the character there was some position which was present in the indices list of each individual character. So we tell it's the subsequence, because it was possible, like there existed a character and all the indices at which it existed occurred at an index after the previous match, so we are telling it's true. So that's exactly how we'll be solving it. Let's go back to the editor and we'll solve it now. Yeah, so now let's write the code. So what do I need here? Index map make, and then I need a map. So map, the key will be bytes because it takes character as key, and value is list of integers because it's index. Now I is equal to 0, len of t I plus plus, and then index map of t of I is equal to append I. So this is basically what we are doing is we are going into t. This is an hash map, index map. Key is t of I. We are appending the index associated with it into this character position, because value is a slice here, basically a list. So the way we append into a list is using this append function. Okay, now let's do the next step. Is 0 traverse through each of the character in S. Now character is nothing but S of I. Now indices comma OK is equal to index map of CH, and if not OK, return false. So what are we doing here? We are checking if CH occurs in the index map. If it occurs, then we'll retrieve indices. If not, this OK will be made to false. So basically, if the CH is not present in the hash map, OK will be false. So that's why we are checking. If not OK, return false. Now let's find an index. So sort dot search len of indices int indices of I didn't initialize position. As I had mentioned before, position is -1. So what did we do here? So this is a way how we initialize binary search in Go. So we use this method to find binary search, and the parameters is the length of the array for which we have to do binary search, and this is a custom comparator function that we are going to use. It basically tells us find an element that is greater than POS. So that's exactly how what we are telling. The indices of j. So for find as an element where indices of j, that element should be greater than POS. So find very first element like that. That's what we are mentioning here. And after that, if indices is equal to len of return false. So if such an element is not present, index will be equal to len of indices. So binary search will just return an index out of the array if such an index didn't exist. In that case, we again return false. If not, we just update the position. Indices of, just update the position. Okay, and then return true. If it didn't become false anywhere in the for loop, that means it is a subsequence, so we return as true. Check this. Yeah, 100% runtime. So code is fine. So let's understand why is this better. So when you have like a multiple strings s1 to sk coming in, it doesn't make sense to check t every single time, right? So because there is multiple string like almost 10 power 9 that is coming, so that's why we are caching t. So cache t. So what happens when you cache t, it will be o of len of t. So only once this will be done, this caching will be done only once, and then when for each of the string we are just going to do this loop, and binary search will take log n time. So n log n will be the time complexity of this loop. So basically the time complexity, if you see for this time complexity o of len of t, that is just one time thing. So let's ignore that, that only happens once. After that it is just o of let if you consider length of s as n log m is the length of t, you think, because this indices length is equal to length of t, because indices comes from t only basically, if you see. So n log m and k times n log m, this will be the time complexity, and caching of t will be done only once of time complexity o of m if you consider length of t to be m. So basically this is much more efficient when you are handling a case where there is multiple s that is coming in, and space will be how much, equal to that we are basically finding this index map. So that is again just one time thing, O of m if you consider it as length of uh, t m, and then indices we are retrieving every single time, that is again m. So yeah, essentially space will be O of m in this case if there is like a multiple stream of strings that is coming in. I hope you understood the explanation. If there is any clarification required, comment down in the comment section below, and also please subscribe. Thank you so much for viewing my video.